In this video, we will learn about the merge sort. Merge sort is a sorting technique to sort the elements of an array, and this merge sort works on two principles. First one is divide, and the second one is conquer. Divide and conquer. And divide means we have to break the original array again and again until we get many arrays of size 1. Why do we get an array of size 1? Because an array of size 1 is already sorted, and thereafter we merge, that is we conquer, by joining these sorted arrays in a sequence to get a sorted array of the original size. So since I have said there are two principles, divide and conquer, so in this video we will learn only about the divide part, and in the later video you will learn about the conquer part. So I type here the divide function. Here you see divide, it is a function, and inside this there will be four arguments. When I type a code for you, then there will be four arguments, but here I type only two arguments. It is because these two arguments which I am going to write is most important, and the remaining two are constant. Those two will not change as the program runs from a point to another point. So those two are not important to understand the algorithm of this divide function. So I write only two arguments here, but remember in the program there will be four arguments attached with this divide function. Now see the two arguments. The first argument is first, and the second is, and if you write in a better way, then one can write int first and int last. These two arguments, and since it is a function, so here I have used a curly bracket, and inside this we take a variable named mid, and thereafter we take a key if, and inside if we type a condition. If first is less than last, if this condition is satisfied, only then the program will run further, and inside if this condition is satisfied, then we take the value of mid as I show you, first plus last by 2. This is the point, mid is the point from where our given array will be divided many times until we get many arrays of size 1. And it may happen that once we got this mid variable, the value of this mid variable, then it may happen that first is again less than last. So again we use the same function divide. You see the same function here is divide, and inside the body of this function you see divide again. So this is an example of recursion, and further it will be divided into two parts, and first will be first, and the last here. For the last I have to take mid because it is the point mid from where our original array has been divided into two parts. And again the second division, for the second division I type divide mid plus 1 comma last. To understand this part I show you an example, and for that I have to take a table. Here I have taken a table. Suppose this is an array, and the elements are 12, 5, 7, 4, 90, and that you know that index starts from 0, so here will be 0. This 0 stands for the index of the first element. Accordingly the index of the second element will be 1, and here will be 2, here will be 3, here will be 4. And you know if we use this formula first plus last by 2, here first is 0, this 0, first is 0, and the last is 4, here is 4, 0 plus 4 by 2, you get the mid as 2. So our mid will be 2. So I have calculated the mid, and mid is 2. Okay, and thereafter as soon as you get the mid, the array will be divided into two parts. I show you. Yes, you can see that the array has been divided into two parts. The first part is an array of a smaller size containing 12, 5 and 7, and the second array is containing 4 and 90. And one you can see that this division has been made by this mid. You know the index of 7, this 7 is 2, index of this 7 is 2, and you know you see that mid is 2. So we have two arrays of a smaller size with the help of this divide function, and one more thing, you see that for the first array, this array, the first index is 0, first equals 0, and the last element is 7 and its index is 2. 2 means mid here, so here is the mid. And when the function divide goes for to work for the second time, then this mid works as the last, because you see this element is the last element of the first array, and mid plus 1, this mid plus 1 here, its index of this 4 is 3. Mid plus 1 is obviously 3 because mid is 2, so 2 plus 1 3. So this mid plus 1 will work as the first index of the second array, and the last was 90 and its index is 4, and same is the situation here for the second array, so last is unchanged. So with these two functions, these two arrays will be divided further, and this division will go until this division will go according to this rule, until we get many arrays of size 1. So far I have given a hint for you, and further division you have to go in the same way, like this, and each function, this is the, you see this blue part is the body of this divide function, and inside this body you see divide function two times. This means that division will continue, and so this is an example of recursion, but you know recursion must end at a point, and that end will be according to this rule. You see, here is the condition. When this condition fails, the recursion stops, and you will see this condition fails only when you get many arrays of single size. And I am leaving this thing to you for homework. Do this thing yourself and see that you are getting many arrays of size 1 or not. And one more thing I have to say, that in the same function divide, we have to write the conquer function as well. What is the conquer function? I will show you in detail in later videos, but here it is important to write the conquer function inside the body of the divide function, because after division you get after continued division you get many arrays of size 1, and you know, to get sorted array we have to merge these small arrays to get the single large array of the same size as the original one. So I type here conquer, and you know, as I have shown to you that the division part has been performed with the help of mid. So in this conquer part, in this conquer function, we have to use the mid to merge the sort merge the smaller size arrays to get the larger one. So here will be three arguments in our algorithm. This is the algorithm. Note the code. In the code here I will take 5 arguments. Here you see 3 arguments because these 3 are important, and these 3 vary when conquer function is used many times. But there will be 5 arguments in the code. The additional 2 will be, first will be the array name, and the last will be the array size, original array size. These two will be the constant. So in this algorithm I have not used those two. I have used only that thing. Those are important to understand the algorithm. So I have taken here first, mid, last. But what is this conquer function? Conquer function is the same. Suppose, just like when, suppose we have two sorted arrays and we have to get a single sorted array from these two sorted arrays, and how we get a single sorted array from two given sorted arrays, I have already uploaded a video, you can see that. But here as well I will show you the same thing again, because this is a little different. So I will show you in the later video about this conquer function. But before that you should do this homework, because this is very important to understand this merge sort. This merge sort is very important. I show you again. First you take divide function, and inside this we take two arguments for the algorithm, but for the code I will take two additional arguments, first array name and the last array size. But to understand the algorithm, these two arguments are important, sufficient. So I have taken here two arguments, first, last. And inside the body of this divide function, we take a variable int mid, and we see the condition first, where first is less than last or not. You see, first means the index of the first element 0, last means index of the last element. Here you see 4, this is the index of the last element. Obviously 0 is less than last 4, 0 is less than 4. So we proceed and we take mid equal to, we define mid, we take the value of mid as first plus last by 2, and after that we divide this large array, taking this first mid is 2, we have calculated mid is 2. So the first division will give us the first small array, that is 12, 5, 7, and the second function, you see divide function, second time this mid plus 1 means 3. So here is the 3, index 3. So these two 4 and 90 will be in the second array. So first division is complete, and thereafter, since I have used divide function inside divide 2 times, then again for the next time there will be 4 divisions, two divisions from this function, and 2 division from this function. 4 divisions there will be. So go and do that divisions and continue to doing this and see what you get at the end. You will get at the end many arrays of size 1, and when you get the array of size 1, then this recursion ends, because for size 1, suppose an array is of size 1, so its index, there is only one element, so index will be 0. So I ask that what is the index of first element, then you will say 0. Then again I say what is the index of the last element of this array, then you will say 0, because there is only one element. So first and last both are 0, so this condition fails, because 0 equals 0, 0 is not less than 0, so this condition fails. At that time this recursion ends. So, and in each function divide, I have taken this conquer function inside the divide function. So inside one divide function there are two divide function. You see, inside one divide function there are two divide function, and one is the conquer function, this conquer function. As I have said that I will discuss about this conquer function in later video, but first here try to understand this algorithm, this divide algorithm, this divide function, and thereafter we will learn about this conquer function. When we learn about these two functions, then understanding of our merge sort is complete. Okay, thanks.